Okay, so now, for today, is anyone actually not have a copy of this? Before I go on.
What is that?
Exactly. Alright, it's right up here.
He said, what is that?
Now, I will go through this item by item because they're in our notebook already. So, I told you guys before, these are in the notebook. This one right here, we did this one a couple days ago. Okay, on your test, you're going to have, listen up, on your test, you guys are going to have same problem, similar problems. So, I went and found it. It's actually on page 43, and it's this problem right here of how to solve for this problem right here. On page 43 in our notebook, that's how to, please tell me you didn't use that.
No, I didn't. That's why I walked outside.
Oh.
I was about to put it on and it was all in my hand, so I went to wash my hands.
Oh, thank you. Appreciate that. Okay, so right here, this problem right here is all over here on the other side. Remember we actually did this on another paper? Whenever you see those, you set up another triangle, and we do similar. So, same problem. Let's go through and do this. So if I start this one and I say I'm going to set up another triangle, so we're going to try and find the length of AC. So what am I going to put over here on AC? X, right? So my similar triangles, I'll just draw it over here again. And it should be B, C, A. This is my X, and this is 20. I have my similar triangle, which is smaller, same letters. So, sine of A. So, A is my reference angle. Mark that. So, let's go through. So, sine, what do we know sine is? Opposite over hypotenuse. So, whenever I'm doing these problems, are you guys even paying attention? When we're doing these problems, okay, sine, cosine, tangent, what is good to actually start by writing on my paper? There we go, yes, that. So it's going to be sum, oh hippie, caught another hippie, tripping on acid. You should be. Alright, it says sine of A is 4 over 5. Sine is going to be opposite over hypotenuse. So from A right here, opposite is going to be where? What line segment? BC, isn't it? Yeah. So what number am I going to put right here for BC? 4. All right, hypotenuse. What am I going to put for my hypotenuse? 5, because that's what I got from right here, right? Next one is cosine of A. Cosine of A is 3 over 5. Cosine is adjacent over hypotenuse. So the number I'm putting in for my adjacent is what? 3. My hypotenuse is 5. Look, it's still 5, right? It's already there. So we have that. Now we can set up our similar triangles. So if we set up our similar triangles, how would I go about setting this up? You said 20 over what? 20 over 4, very good. A couple different ways of doing it. So 20 over 4 equals x over 5. Is there one? Does that make sense? This should be pretty straightforward, right? We have been doing this for a while with the similar triangles. Cross products, 100 equals 4x divided by 4. X is 25. So let's take a look. My answer easy enough. Okay, so let's take a look at the next one here. Okay. Next one is right here. This one's just weird. It's a weird thing. So, if these two triangles are similar, they have the same ratios. Okay? If they have the same ratios, whatever I get, I'm going to have the same ratio here. It doesn't give me any values for this one. So, I don't like this question, but it doesn't. If it gave me some values, I could actually plug in and use the scale factor to figure out what these are. But I don't have any values here, so I could assume since they're similar, it's going to have same ratios. So if cosine of D is 12 over 13, so let's see. Cosine adjacent over hypotenuse, right? Adjacent, hypotenuse, opposite. So it's going to have the same ratio over here. So it's basically going to be the same numbers. So 12, 13, and 5. So now it's asking for the sine of C. C is over here now, right? So it's changing this. Now I'm looking at it from a different side. Sine, again. Sine is what over what?
Opposite over hypotenuse.
Very good. Opposite over hypotenuse. My opposite of this one is going to be 12 over 13. Very good. Cosine of C. So cosine from here is going to be 5 over 13. Tangent of C?
12 over 5.
12 over 5, right?
Yeah.
12 over 5. It's that easy. So as long as we don't have earbuds in right now that I have to might take them away. So please take them out so I know that you're paying attention. Not hide it more with your hood. Take them out so I know you're paying attention.
You're out.
Oh, okay. All right. Thank you.
Mr. Spencer, are you recording?
Yes, I am.
Hi guys.
You're probably just ending up talking to yourself, or talking to that one person that watches my video every day in 6 hour.
Is that one person?
Not you. Now, let's take a look at number 3. So, sine of D. This is a similar problem. I can go find this one in the notes again. So, if I'm starting with something like this, if I start with a decimal, I need to go fix that. Here it is. It is right here on page 44. On page 44. So if I start with a decimal like I do here, what do I need to do with that first? Convert it to a
Fraction.
Very good. So take your decimal and convert it to a fraction. So please everyone do that right now for this problem right here. So it's going to be sine of D is equal to, what is that as a fraction? 6 over 10, or if you did it on the calculator, you come up with what? Your calculator will reduce, that's why.
Oh, alright.
Is that a B?
Yes. Oh, it should be D, I'm sorry. Yes. 4 over 5? 3 over 5? 3 over 5, right? Because 6 over 10 will reduce into the 3 over 5. Yes?
Yeah.
Alright, AC, this value right here is 10. What is BC? What am I going to put right there for BC? I'm going to put what? X, that's where I'm putting my X. Now, D is right here, right? So here's D. That's D. We know sine is opposite over hypotenuse. So where is the 3 going to go? Give me the line segment where 3 is going to go. FH, right? FH, so that's going to be a 3. Where does the 5 go? DH, very good. That's what I'm looking for. So now, do I have everything I need to set up my cross products here?
Yes.
Yes, I do. Let's go ahead and do that then. So what did you say? 5 over 10? And 3 over x? Okay. 5x is 30. Divide by 5. X is There we go. So, what is the length to BC? X equals 6. Muy fácil.
When's the test again?
Wednesday, Thursday. I'm going to give you 2 days. Alright, so number 4. Darren started with the triangle. It looks like this. Okay? So 5, 12, 13 triangle. And reflected it horizontally. So 5, 12, and 13. Where are those numbers going to go? Where do you think, so let's start with this one right here. Where do you think 5 is going to go? HK right here, right?
Yeah.
So that's 5. Where's the 12 going to go?
KI.
KI, very good. And 13?
HI.
HI. Very good. So in these type of triangles, okay, hypotenuse is always my longest side, right? So when I'm reflecting this, what is JK going to be? 5. And what is JI?
13.
There we go. So we filled in everything. Okay. So HK is 5 centimeters. HK, very good. Okay, since HK is 5, then JK is also 5, right? Because they're congruent. Pythagorean theorem, HI is 12. HI, okay, wait. HI is 12 and KI is 13.
Yeah, the promise is that he went wrong somewhere and then just
Okay, where'd he go wrong?
on the second one he's gonna put that hand
Right here?
Yeah.
Because HI is supposed to be 13 and KI is 12. So this is where the mistake is, right? That's where I went through and actually filled in everything I could at first and then read through this line by line to see if there's a problem. That's where my problem is, right? Okay. So tan of IJK is right here. So this is the angle I'm looking for. Tangent is always opposite over adjacent, so it should be 12 over 5, right? So this is also wrong because this is wrong. Okay, went wrong somewhere. Find his mistake and correct it. So we said that HI is how much? 13, and KI is 12. And then if I do this, if I correct this part also, I would say, so tangent of, this is going to be angle IJK, is going to be, the tangent is always opposite over adjacent. So what was opposite?
12.
12. Adjacent is?
5.
Very good. That should be 12 over 5. Now, by justifying every step that you're doing here, go through, read it, fill in. The number one thing people have in here mistakes on is actually reading everything. Okay, does everyone actually have their test?
Test?
Yeah, I know this review, right? So, this review should be on everyone's desk right now, right? Please tell me you're not trying to kill me with that. I'm allergic. Can you not put it on? I am allergic. You want to go wash it off? I would appreciate that.
Nacho silent assassins.
I know, right? Yeah. Could you, please? All right, so let's take a look at the next one here. Okay, different standard, changing the standard, SRT 7. So, let's find this in my notes. Okay, SRT 7, that looks like sine and cosine. That one is right here. It's complementary. Page 43 again. Okay, complementary. Here they are down here. It goes right along with this problem right here. Yes. Yes. When, you find Josue, tell him that, he's in trouble.
It always takes like 30 minutes.
Sine is here. Find it in terms of cosine. So to write this out, it would be sine of 39 is equal to the cosine of
It's 51.
it is, but I want to show explanation. Show me the reasoning for this. What numbers go here?
90 minus.
Very good. So it's 90 minus 39. So it's going to be sine 39 is equal to the cosine of 51. And can you give me a reason? Can you give me a word that would tell me the reason why?
Complementary.
Complementary. That's what I'm looking for. Okay, explain how they're so.
Can I get a paleta for that?
A what?
Never mind.
So they're complementary.
About time.
You take too long.
Yeah, it's just I was 4 minutes.
Okay. This one right here. In the picture below, A and B are complementary angles. Which statement is true? So let's take a look. Cosine of A. So I'm going to look at it from A, then I'm going to look at it from B. Okay, I know this is my hypotenuse. That doesn't change. But it changes when I look at it from different sides. Cosine of A is going to be adjacent over hypotenuse, right? Adjacent over hypotenuse. So the adjacent value is what? 10.
Yep.
Yeah.
Hypotenuse is 25, right?
Yeah.
So 10 over 25, that reduces to 2 over 5. Right?
Yeah.
Hold on, go slower. Oh, okay, yeah.
Okay. Because it's asked for cosine, right?
Yeah.
Okay, so I did it here. Now I look at here. Is this right?
No.
No. So I'm going to put an X that one. Okay, let's take a look at the next one over here. Cosine of A is 2 over 5. That's what we came up with, right?
Yeah.
Now let's try sine of B. So here's B right here, right? Hey, this is what I gave out the other day. Were you here Friday?
It's wrong.
Okay, let's see. Sine of B. Sine is opposite over hypotenuse, right? My opposite here is 10. My hypotenuse is,
25.
so that's not going to give you that one, right? So the cosine is right, but the sine is wrong. So cosine and sine are both equal to 3 over 5.
No.
Is that true?
Not them.
No, it's not. It's not 3 over 5.
It's BD.
Cosine of A and sine of B, 2 over 5.
Yeah.
Yes, they're both 2 over 5, so my answer is going to be this one. Okay, you have to make sure you look at it from each side of that angle. All right, how do I go about solving this one right here?
You have to make sure they add up to 90.
They will add up to 90, right? So if they're adding up to 90, I would write x plus 36 plus 4x plus 9 equals
90.
90. Very good. How many x's?
5.
Very good. 5x plus how much?
36 plus
45 equals
9. 90
90.
divided by 5.
No, not yet.
Minus 45.
To what?
Subtract 45.
Subtract 45. 5x is 45. What goes next?
Divided by 5.
Very good. Divided by 5. X is
9.
9. Very good. Now, what is part B saying?
Where's the value of the angle?
So what should I do to find the value of the angle?
Add 9. Input 9 for the x's.
Very good. So I'm going to evaluate it. So I'm going to put 9 into the x's. That's very good. That's what I'm looking for. So 9 plus 36.
45.
Oh.
Yep. So this is 45. And 9 times 4
45 too.
is going to be 36 plus 9. So it's again 45. Why do I know that they work?
Because they add 90.
They add up to 90. They're complementary. That's what I'm looking for. Good job. Yeah, you might actually do pretty well on this. As long as you don't spend your whole weekend doing Fortnite.
What's it says?
Test is going to be Wednesday and Thursday.
In our journals, we do Wednesday.
Yes. So I'm going to take them on Wednesday. Because I need time to actually grade 2 classes of them.
Oof.
Starbucks needs build a wheelchair ramp with a length of 30 feet and a height of 3 feet. 30, 3. Isn't anywhere, someone in a wheelchair go a drive-through?
What? That doesn't even
Hold on,
make
say
sense.
that again.
No.
I was not sure.
If you're in a wheelchair, aren't you driving through everywhere?
Yeah.
You rolling through there?
Okay.
So like they want to
You can really say you rolling down the streets
Yeah.
in my 6th floor.
Oh my goodness. You go ahead. Do that. All right. So, what is the angle of the wheelchair ramp makes with the ground? So we're looking for this one right here. What am I going to put there if I'm looking for that?
Okay.
Not x.
Theta.
Theta. Why am I going to put a theta there?
Because we're looking for an angle.
Looking for an angle.
Oh, you right.
We use theta for the angles, right?
Yeah.
Theta for the angles. So that's going to help you out. Now, class, if I'm looking for an angle, I have to use the
Inverse.
inverse. Thank you. That's what I needed. All right. So from here, this side is the
Opposite.
opposite. Put an O there. This side is
Hypotenuse.
hypotenuse. And,
Adjacent.
hey. Come on now. What am I working with here?
Sign.
Sine.
Ah.
So it's going to be sine theta is equal to what?
The in 3 over 30.
3 over 30. Very good. 3 over 30 because sine is always opposite over hypotenuse, right? And so this is the point where it changes, right? Where I'm trying to get the theta by itself, I have to do the inverse. So from here, it's going to be theta equals inverse sine of 3 over 30.
Oh, no wonder mine's in
And your calculator has to be in
Degrees.
degrees. My last class, first hour, was doing everything in radian. So if you put in your calculator, you're not coming up the right answer. So let's go ahead and change them. So that's what I'm doing right now. I'm going over to show you guys how to change it. So I'm hoping everyone's paying attention. Menu. So I'm on the scratch pad. I go menu, settings. That's number 7, right? Document settings. I'm going to use the scroll pad now, so change that to degree. And then down here, make default. There we go. Okay, now you ready to do it?
Yeah.
Okay, let's see. So inverse sine. So trig. Inverse sine of 3 over 30. So my angle is going to be what? How many degrees? Not 57. So it's going to be 5.7 degrees. Okay. State of Arizona requires wheelchair ramp be less than 4.8. What is the minimum length Starbucks must build the wheelchair ramp to meet the standard? Round to the nearest 100. So, is this ramp too steep? Yes, for someone in a wheelchair, trying to go up a steep hill, it's a pain. So they made a standard, no more than that. This one is too big, right? So that means that it has to be a certain number. So let's go ahead and do the same thing again, but now if it's going to be sine of 4.8 degrees is equal to, let's say 3 over, now this one right here, I'm going to put an h because that's going to be the hypotenuse that I'm looking for here. Because this one is too steep, I want a different value here. So I want a different ramp. So I need a longer ramp because of this. So the longer the ramp, the shorter the angle. So what would I do to both sides of this equation right here?
Multiply by 8.
Very good. Multiply both sides by h. So it's going to cancel that out over here. H times sine of 4.8 degrees is equal to 3. What would I do now to try and get h by itself? Divide by what? Sine of 4.8, right?
Yeah.
Very good. Let's do that. H equals 3 divided by sine 4.8 degrees. What is it going to be? 4.0?
3.
That sounds better. 35 sounds better. So it's 3 divided by,
I put 40 in, no wonder.
okay, so let me see, 3,
It's because I didn't put the point, that's why.
okay, sine 4.8 degrees.
Yeah.
So I should come up, and it said round to the 100th. Which place value is 100? The second one, right? So let's look at the third. So it's 35.85. Does the 1 make it go up? No, it drops off. So it's going to be about 35.85. What are my units? I heard it. Feet. Yeah, long ramp. Okay, so let's take a look at number 9. On number 9, which expression can be used to find the value of the x in the triangle? Okay, so let's take a look. So I have this value. I know that this is 33, right? Okay, so from there, from that side right there, I know that if this is 33, this side over here would be my opposite, right? This side over here is adjacent, and this one is hypotenuse. So I usually go hypotenuse next, but I went to, sorry. So let's see. What am I working with here now? I would be working with the opposite and the adjacent, right? So what's that going to be?
13 over.
Yes, but what ratio is that? Tangent, very good. So that's going to be tangent of 33 is equal to 13 over x. So x is down here. We're not actually doing the math, we're trying to set it up. So I'm going to multiply by x times tangent 33 is equal to 13. Divide by tan 33. Okay, so 13 over tan 33. Okay, so this one says choose all that apply. So is this one going to be right? This second one, no. Is this third one going to be right? So tan 33 divided by 13?
No.
No, that one's wrong. Okay, so now where'd this 57 come from?
Moving.
Think about it. Where'd the 57 come from? These two angles together have to add up to 90, don't they?
Oh, no. Yeah.
So this side over here is going to be 57. Now, if this is 57, this side over here is now going to be the what?
The opposite.
Opposite. That's all. That's going to be an opposite. This side is still my hypotenuse, and this is my adjacent. So now from 57, from the 57, what am I working with? Opposite, right? And adjacent. So opposite adjacent is going to be what? What's my ratio? Tangent. That's what I'm looking for. There you go. So tangent of 57 degrees is equal to x over 13, right? Opposite over adjacent. So x over 13. Now to solve for this, what would I do? Very good. Multiply by 13. Yes, that's what I'm looking for. So those cancel. So 13 times the tangent of 57 degrees is equal to x. Yes, no, maybe?
Yeah.
So, is the answer D? No. Is the answer E?
Yeah.
So we have two answers on this one, don't we? Number 10. Given the following information, solve for the length of the wire, round to the nearest tenth. So, from this angle right here, this side over here is going to be the opposite. Come on now. This side over here is, and down here, what am I working with? Sine? Very good. Opposite and hypotenuse. So it's going to be sine of 70 degrees is equal to 50 over x. Yes?
Yeah.
Okay. Multiply both sides by x. X times sine of 70 degrees is equal to 50. Now divide by sine 70. X is 50 over sine 70. And in your handy dandy calculators, give me this and round it to a tenth. 47 what? I don't like 47. 53?
Yeah.
That sounds better. So 53 point something? Let me see. 50 over sine 53.2.
Yeah, you can choose scaling up.
Okay, 53.2. There he goes. There we go. And that's going to be in feet. Don't forget, you always have to label your units to get full credit.
Can you show me how to put it in decimal form?
Decimal?
Yeah.
What do you mean, like this?
Yeah, you know how you like went to like settings or something?
Oh, that's just the degree, not decimal. DEG?
Yeah.
Is that what you're asking for? Okay, so do it again. So I'm going to do it quick. Hit document. Number 7. Number 2. And then you make default when you're done. Okay? Alright, let's take a look at 11. 11. This problem was one of your practice problems here. Flying a kite, angle of elevation. So angle of elevation is from where to where? If you elevate, you go up. So it's from the bottom up, right? Angle of elevation. So it's going to be here. That's going to be 23 degrees. If your eyes are 5 meter. Oh, your eyes are 5 meters high. Good lord. 5 meters. Yeah, a meter is longer than a yard. So this person is over 15 feet tall. Anyway. How high off the ground is the kite? Round your answer to the nearest tenth. Okay. Length of string is 50 meters. So this is 50. And how high off the ground? So I'm going to put an X right here because I'm looking for this. I'm looking for this right here, right? And when I find this, what am I going to do with that answer? Add what? Is this off the ground? Isn't this person off the ground right here? If this is the ground, this person is apparently 5 meters off the ground is where this triangle starts. So once I find this value right here, I need to add 5 because the triangle don't start on the ground. If the triangle started on the ground, then I would just find this. But then once I find this, I have to add 5 to that. So let's take a look. From this reference angle, this side is? It's going to be sine, yes, so it's opposite and hypotenuse. Sine of 23 degrees is equal to x over 50. Multiply by 50. I think my pen just died right now. So it's going to be 50 times sine of 23 degrees is equal to x. Right?
Yeah.
Put that in the calculator. So let me see. 50 times sine 23 degrees. 19.5, right? To the nearest tenth. So this x is 19.5. And these are meters, right? And this is not my answer. What do I have to do to this answer?
Add 5.
Add 5 because I have to add this height right here, right? I have to add this height, which is 5 here. So plus 5. So it's going to be what? 24.5 meters. Because that's 5 whole meters, right? So this is actually 5.0 meters, like that, if you're lining up the decimal. Yes?
Yeah.
All right, so keep going. Got about a minute. Got a couple minutes, actually. All right, so shark, 32 feet below the surface. Okay, now, hey, don't get up yet. Okay, spots a baby seal. Given information in diagram, how far would the shark have to swim to get to the seal? So I'm looking for shark to seal. So right here, this is shark bait.
Cool.
There we go. All right. So let's first have to find a couple of things here. I need to find this value, so I'm going to put a y over here. And you know what? I think I'm going to run out of time right now. You know what? I will add this to the other video, so if you guys ever want to come and check it, I know I'm going to have like one person watch it. So this is a very good review.
Just say to be continued.
To be continued, right?
That's the suspense.
Yes, same bat time, same bat channel.